Welcome back. Today we're going to talk about derivative as a function. The last time I introduced the derivative and I mentioned that the derivative at a point is basically the slope of the tangent line at that specific point. What we're going to talk about today is to discuss the derivative as a function. That means every time you want to find the slope of the tangent line, you don't need to go back and say, okay, I'm going to go through this whole process over and over. What you can do is simply you can find the derivative function, and if you want the slope at a specific point, you replace that point in the function. So here, if you compare the definition of the derivative that we had for a point and the derivative as a function, they are very similar. The derivative at the point was f prime a at the point a is going to be limit f of a plus h minus f of a divided by h as h approaches to 0. This was one of the definitions. What is the derivative as a function? Is you're not given this a value. We still assume that it's an x, and we do not know what that x is. So we're solving as a function, a variable. It's still the same difference, quotient, everything is the same. So let's go through it with an example. So here, given the function f prime x, we're given the function f of x, we want to find out what is f prime. So here, f prime x, I'm going to use this definition. Find out, first you need to figure out what is f of x plus h. Because in the formula for the difference quotient, you need both f of x plus h and f of x. So let's try to do this. Figure out what is f of x plus h. Replace x plus h every time you see x. So 3 times x plus h plus 1, and denominator would be x plus h minus 2. Okay, I'm going to distribute the numerator just to write the simpler form. 3x plus 3h plus 1 divided by x plus h minus 2. Okay, now what we're trying to calculate again is f prime. So let's use that definition of f prime x. It would be limit h approaches to 0 of f of x plus h, which is 3x plus 3h plus 1 divided by x plus h minus 2, and minus the f of x. F of x is already given, 3x plus 1 divided by x minus 2. And this is divided by h. This, breaking it up step by step, what I'm doing is normally called the 4-step method, but I don't want to give it names or whatever. So if you heard 4-step method, this is what it means. It means first find out what is f of x plus h, then write the limit, then try to simplify, and at the end replace h with 0. So again, we're going to follow up with simplifying. If you replace h with 0, the denominator would be 0, numerator as well would be 0, so it's not going to help us. So somehow we have to get rid of this h in the denominator. What we need to do first is to use common denominator for the numerator, make the same fraction, make the same denominator for the fraction. So what I'm going to multiply to the first one is I'm going to have 3x plus 3h plus 1 divided by x plus h plus 2, minus 2. This is the fraction for the first fraction. The second fraction is 3x plus 1 divided by x minus 2. All this is divided by h. If I want to make common denominator, I should multiply the top and bottom in the first fraction by x minus 2. And in the second fraction, I should multiply the other fraction's denominator. I'll multiply x plus h minus 2 and x plus h minus 2. Now they both have the same denominator. So equals to limit this h approaches to 0, still h in the denominator. They both have the same denominator, the two fractions, so I'm going to write them as x plus h minus 2 and x minus 2. And the numerators are becoming 3x plus 3h plus 1. You can skip some steps. I'm going to write it for the first example. After that, you can skip ahead. X plus h minus 2. Okay, so now numerator, simply you can distribute every term. You do this for all the terms, and the same for the other one, and try to simplify. 1 times this, 1 times that, or whatever. So equals limit. This is gonna be a bit too many terms, but I'm gonna try my best to write everything down. X plus h minus 2 and x minus 2 here. Divide by h. Okay, so the numerator. 3x times x would be 3x squared. 3x times negative 2, negative 6x. 3h times x would be plus 3xh. 3hx doesn't really matter the order. 3h times negative 2 minus 6h plus x minus 2. And for the first, this is the first part. The second part, you have minus 3x times x, so you get negative 3x. I'm multiplying this negative at the same time as well. You can distribute first and affect this negative sign. So you have 3x times x would be 3x squared, but the negative sign makes it negative 3x squared. 3x times h would be 3xh, but the negative again makes it 3xh. And 3x times negative 2 minus 6x, negative makes it plus 6x. And the same, 1 times x becomes positive x, that negative makes it negative x. 1 times h, so minus h, and plus 2. Okay, now I'm going to cancel out the similar terms. Negative 3x squared, 3x squared. Negative 6x, positive 6x. Here's plus x, negative x. Minus 2, positive 2. One hint is that whatever is left at the end, in this case actually 3xh and negative 3xh will cancel out. So whatever is left at the end, we compare these, whatever we have here, is you should have only stuff containing h, nothing more than that. So there is no other term beside terms with h. So here in the numerator you have negative 6h and negative h, so minus 7h. Okay, so what we have is, write this in the next line, limit, the numerator becomes negative 6h and negative h left, so minus 7h, divide by x plus h minus 2 and x minus 2. Again, you don't need to multiply the denominator, since at the end we want to replace 0 for h. So these two now I can cancel out. The whole purpose is to cancel out the h in the denominator. So what is left is limit negative 7 divided by x plus h minus 2, x minus 2, as h approaches to 0. And now replace 0 for h. So if you replace 0, what do you get is negative 7 divided by x plus 0 minus 2. So you get x minus 2. This is 0. We're replacing h with 0. And then you have another x minus 2. You can shorten it to negative 7 divided by x minus 2 squared. Okay, so what did we find is one function. Negative 7 divided by x minus 2 squared. But this is the derivative function, so f prime x. So if they would have asked you for the slope, so the same question, if I ask you the slope of the tangent line at the specific value of x equal to 1, for example. So if I ask you what is the slope, change this color to make. So if the question was the slope of the tangent line at x equal to 1, then you should have replaced the 1 f of 1 plus h minus f of 1. But if you have the derivative, slope of the tangent line at a specific point basically means the derivative at that point. So I already found the derivative function, so I can replace 1 here. 1 minus 2 squared. And I can say, okay, this is negative 7. So I already have the slope of the tangent line. So this is, having this derivative function actually helps to calculate the slope at any point without going through the process over and over. So This derivative function is going to give you the slope at every location. Okay, so here's an extra notation. The derivative function, f prime x, another way to show it is using y prime, derivative of y, with respect to x. So they write d of y with respect to variable x, so dy over dx. Derivative of the function with respect to the variable of x, so df over dx. All these have the same meaning. That means the derivative function. That means what we found here, f prime x. If you see d over dx of f, that's the same thing. The capital D of the f function is the operation of derivative with respect to x of the function f. These are all notations that have the same meaning. Normally the ones that we use are these first three, or maybe the fourth one as well. Okay. So derivative, for simplicity, normally I'll use the prime, but if you see dy over dx or df over dx, that is still the derivative with respect to the variable x. Okay. Now that we did an example, let's mention this important thing. A function has derivative at a specific point if the tangent line at that point exists. If the tangent line does not exist, then there is no derivative at that point. That means the function cannot be differentiated at that point. So when we say a function is differentiable at a point a, that means the derivative at that point should exist. That means the slope of the tangent line exists. That means the tangent line exists. So if you're dealing with a function like absolute value of x, think about this. Absolute value of x, let's calculate the derivative. You can calculate without graphing, or you can calculate with the graphing as well. But graphing helps maybe to understand. So this is the absolute value function. Right, this is a straight line, 45-degree angle. So let's look at the specific point, maybe here. If I pick this point and say, draw the tangent line at that point. Tangent line turns out to be straight line. It's just going to be exactly the same. But if I look at the point 0 and say, draw the tangent line, you cannot draw this. You cannot draw this. You should draw this line and say, okay, this is the tangent line. Kind of you following the straight line. But on the other side, if I look at it, it's this line. So what it means is that you have two different slopes depending on which direction you're looking at it. That means the limit that you're calculating is going to give you two different values. You can do that. You can calculate here to see, if you remember, absolute value of x was a piecewise function. It was x. If x is greater than 0, x less than 0, you'll get negative x. So here, if you try to calculate the derivative, limit f of x minus f of 0 divided by x minus 0, this is at x approaches to 0. This is to find the derivative at f prime at 0, the derivative at 0. This is one of the definitions. The other one was x plus h. In this case, I'm going to use this definition just because you're given the f function and there is no h necessary. We can look at 0 already. It's not going to make any difference. You'll have f of h minus f of 0 divided by h minus 0, still the same. Okay, so here, what is the f prime function? Let's calculate. Limit f of x. What is f of x? F of x depends based on the value of x. So it could be either x or negative x. So I'm going to break up the limit into two parts and say, okay, I'm going to assume x approaching to 0 from positive side and x approaching to 0 from left side. And in each case, I'm going to calculate the derivative. So limit x approaching to 0 from right side of f of x would be x. This right side would be the first part of the graph, the function, the right part. So x minus, the absolute value of 0 is still 0, divided by x minus 0. What would be this limit? You can simplify x minus 0 is x minus 0 is x, divide them by each other, simply 1. And if you do that for the left side, numerator is the f function, f of x. F of x on the left side is negative x. So I will have negative x minus absolute value of 0 is still 0, divided by denominator is still x minus 0, as x approaches to 0 from left side. What do we get in this case after simplifying is negative 1. And what does it mean is On the right side, what did you have as the slope? This dashed line is the slope 1. On the left side, the other dashed line has slope -1. So it means the tangent line at that point, at the point 0, is basically have two different slopes. Not possible. So you cannot have a unique result. Therefore, derivative at that point does not exist. We will mention at what points derivative exists or not based on the graphing, but you should be careful in the cases when the function is piecewise. You have to be careful to see if this transition is kind of smooth. So it means the derivative exists at that point or not. The tangent line exists, and is the limits on both sides are unique or not. So here, this was an example of where the function could not be differentiable. At 0, in this case, the absolute value function is not differentiable. But through the graphing, you can see certain cases the function is not differentiable. One is when you're dealing with a corner point. So if you have a point like this, at A, let's say A is here. This function f is not differentiable for the same idea that if you draw the tangent line at this point, the tangent line on the right side will look like this dashed line. Let me draw it as a straight line. This would be on the right side. It should be smooth and touching the graph. And on the other side, would look like this. So what would you have is two different slopes because you get two different tangent lines. But the function cannot have derivative at that point. So here f prime at the A does not exist. Similarly, if you have a discontinuous function, then you cannot talk about the value, the limit from right or left. So therefore, here tangent line on the right side may be something like that, but the value on the left side is not continuous. So in the case of discontinuity, the function does not have any derivative at that point. So f prime A does not exist either. And there is a third case that, for example, if you look at the cube root function, this happens in the fifth root, cube root, something like that. What happens to the derivative is kind of the derivative, the tangent line, it's going to turn out to be a vertical line. So the tangent line will try to be smooth at this location A on both sides. So what you get is a line that is vertical. And what do we know about the vertical line? We know that the slope does not exist because there is no change in x's. The change in y divided by change in x, the denominator would be 0. So there is no slope. What is the slope of the tangent line? Is basically the f prime. So f prime would not exist if the tangent line is vertical. These are the three cases that through graphing you can see that the function is not differentiable at those points. Okay, so differentiability is kind of important to know, but through the process you will notice that the derivative would not exist. For example, if you go back to the original case that we had here, you cannot talk about the derivative at 2 because it makes the denominator 0. But 2 was not in a domain at all to be able to talk about it. That's one thing that we should be careful about as well. So if a point belongs to the domain, and the only time that it's not differentiable is if one of these three cases happen. Okay, higher derivative. Higher derivative is something that it's only in notation is different. Instead of having one dashed line, maybe you have 2 prime notation. That means the second derivative. Sometimes you can write, so here the second derivative could be written as take a derivative d over dx, take a derivative of the derivative function, the sort of derivative function. You can write this d squared of y divided by dx squared. You can write this d squared of f divided by dx squared. Or you can simply write f double prime or write y double prime. That means the second derivative. If they ask you for the third derivative, y triple, y to the fourth or whatever, at some point you don't want to write 10 of these. So what they do is after a certain number, they write in parentheses 4. That means the fourth derivative, but they mention that this is the derivative. Let's not get too far ahead because normally after the second derivative, the third derivatives are and so on. It's not very useful for us. The notation just to know that for each prime you will consider the derivative, or if you write d squared, this tells you the derivative with respect to the variable x. Okay, so here is an example. Given f of x as x squared plus 1, we want to find out the second derivative. And how do we do it is you go through the process of derivative twice. So I'm going to do that and say, okay, let's first find out what is f prime x. After I find f prime x, I will use f prime x to calculate the derivative one more time. So f prime x would be limit f of x plus h minus f of x divided by h as h approaches to 0. So here, f of x plus h, let's figure out what is f of x plus h. X plus h squared plus 1. In the function f, I replaced x plus h. And you can square this. It would be x squared plus 2xh plus h squared plus 1. I hope everyone already knows this. Limit, you can write it twice, this parentheses, and multiply it by itself. You can write it as x plus h times x plus h. This is how you get this x plus h, x squared plus 2x plus h. And distribute. But this is the shortcut. Okay. Erase this. Okay, so I have the f of x plus h function. So I replace it. It will be x squared plus 2xh plus h squared plus 1. And minus the f function minus x squared plus 1. And I'll divide by h as h approaches to 0. Can we cancel out terms? X squared minus x squared will cancel out. 1 minus 1 will cancel out. This negative sign is subtraction. So what we have at the end is limit 2xh plus h squared divided by h. And if you notice, every term contains an h. That means we can factor out that h. So this is limit h times 2x plus h divided by h as h approaches to 0. These two can cancel out. We have limit 2x plus h divided by as h approaches to 0 divided by 1, doesn't really make any difference. And now replace h with 0. You'll get 2x plus 0. Means it's 2x. So what is 2x? This 2x is the derivative function. I'm going to write this and say, okay, I found the f prime. Is 2x. But the question was not to find the f prime, it was to find the second derivative. So what it means is that assume now this is the new f and do the same process for this guy. So what it means is calculate f of x plus h minus f of x divided by h as h approaches to 0. But not for the f function, but for the f prime function. Do it for the f prime function. You can call this a new f or do it for that or whatever. But this is the main idea, is you continue to do this process. So it will be limit h approaches to 0. We need to figure out what is f prime x plus h. So f prime x plus h would be 2x plus 2h, 2x plus h, which is 2x plus 2h. It would be 2x plus 2h, and minus f prime of x is 2x, all divided by h. This is a simple case of limit 2h divided by h, because these two can cancel out. And h approaches to 0, you can cancel out these two. Limit of a constant, that's constant. So what we found at the end is the second derivative. This was the second derivative. So the second derivative, simply 2. We already have the first derivative. We found the second derivative. So if you're looking for the third derivative, you should continue this procedure. Try another function. This is a good example, but the work is kind of too much. So if you know how to do it once, you should be able to continue the procedure over and over. Okay, I'm going to stop at this point. This is the end of section 2. Next time we'll continue on 2.3 differentiation formulas, and we will find shortcuts Instead of going through all these procedure over and over, we'll find there are rules that you can apply. Instead of calculating these limits, you can get the answer from the original function. You can simply reach to the derivative. Okay.